Hi, my name is Stefania and I'm gonna present you my final project for the MySQL translation system. So first I'm gonna give you a little background of the situation. There are a lot of companies that have their information stored in Excel sheets and even paper sheets that when the company gets bigger, they can't save anymore the amount of data that they're receiving. So they want to implement a functioning database to have a record of their information and be able to access it more quickly. At this point, they contact an expert to do the translation of data from the Excel sheet, for example, to the database. But this expert needs to know the right data type for each column of the table. This could be easy if you have a table of 3 columns, but most of the times they have tables that have a lot of information, so the process of data type matching gets a lot more complex. This is a situation that is present in a lot of cases, like mechanic workshops, electronic workshops, restaurants, supermarkets, basically companies that start small and get bigger and bigger and can save their information in the way they want anymore. Because of this is a system that could be implemented in a different amount of cases, like the ones I already mentioned, and you have the ability to change parts of the system to match it better to the needs of the client. So the objectives and requirements for this project are the first objective, to reduce the time spent in the data translation in 32% in a span of 2 months since implemented, and to reduce the possibility of mistakes to 10% from the date of implementation. We'll talk about this a little bit later. And the functional requirements are to decipher the correct data type to each column and to develop the code to create a table in MySQL stating the right data type for each column. So what is the real relevance for this project? We already established the conflicts that this situation brings in the real life, like the company and the problem itself, but what does it involve for the developer itself? So first of all, I need to mention that this is what it's called a ETL process, which translates to extract, transform, and load, where you take information from a source and transform it to be able to load it into a new source. So these kind of processes are really used in the information technology scope because, as I said, there are a lot of cases that need to translate some data to another component, to say it somehow. And when an expert is faced with this process, they have to take into account a lot of different information. In this case, where we want to translate the information from a source into a database, they have to take in account, for example, the database management system that they will be translating the information into. Because in this case, we are using MySQL, but if they use a different system, the syntaxes of the statements put in the file are going to change. Another thing that is important is that the translation must not only match the data types to the values in the table, but also to the company's priority. Because in this case, we want the priority to be speed. But some companies may want accuracy, precision, memory storage, and other things that are going to affect the data type choosing for the new database. What do we want the process to be? The translation process basically has 6 steps. Obtain the table gotten from an Excel CSV format, go through the columns of this table, know the data type to which each column should belong to, give this information to the expert, create the new database table, and implement that into the real database. Well, now we're gonna step into the data structure analysis. So what I needed for my system was basically 3 things. 1, a table to store the CSV data gotten from the Excel sheet, a table or list to store the data types that the system is going to be able to match, and something to save the statements for the database table into. So what I did first was to establish like a little list to know what my system needed the structures to accomplish. So first we say that the tables have a defined size since the beginning. This because you get the CSV that is information directly from the company. You're not going to change the size because you're not going to insert any more values or delete any more values because that information is classified from the company. So you're not going to touch it more than to match the system. Then we need to be able to access the information stored quickly. As we said, the speed is a priority for this project, so we need to access the information quickly, and we can use that as an advantage to be able to access the information through keys, because with a single number you can get an element from the table that you're looking for instead of going through each element to find the one you're looking for. We don't need to delete or insert any values, as I mentioned, and the entire table is going to store string values because the CSV gives you the table directly in a string format, so you don't need to use any other data type. So then what I decided was to use an array for the table of the CSV, an array to store the different data types that the system can match, and a file, as I mentioned before, to store the code created to implement the table with the right database. So why did I take these decisions? Well, first of all, we know that an array is a finite group of data that is located in a contiguous memory location. This can help us bring the speed priority of the system that we mentioned before, because having the data in a same location is going to help you go through this information more quickly. Rather than when you use a linked list, you have to access its content through pointers. So the fact that it is in a contiguous memory location also helps us have no wasted space in the memory. Also, the elements stored in the array are accessed through a key, which is something that we already mentioned before, and it can help us also make the speed of the system going through a key when accessing the information rather than going element by element to find the one that you want to access. It is fixed in size, which it means that it is a static data structure, and this could be a downside to a lot of problems, but in our case it isn't, because as we mentioned before, the table is not going to be touched after its creation, so we can deal with that characteristics of arrays. And I also use the big O complexity to compare this data structure to other ones to be able to know if arrays are the right choice. So according to the system needs, I decided to compare arrays to linked lists, queues, and stacks to be able to match the system to the needs. So the big complexity depends basically if the system is being efficient in the way it is manipulating the data structure. So, for example, arrays have a big O complexity in accessing of O1, which means that no matter how big the table is, the process of accessing this table is going to be in the same time always. So this is really important for us because, as I mentioned, we're going to be accessing this table in a lot of times throughout the system. So rather than using, for example, linked lists that have a big O complexity of accessing of On, where they have to go element by element to be able to access the one that they want. So that is really important for our system. And we also see that the delete and insert big O complexity of arrays for the system is On, which means that the process does require the size of the table to be able to do so in a proportional period of time. So we see that it is On, but we don't really care about this aspect because, as I said, we're not going to touch the tables, we're not going to delete or insert anything. So it's not something really important for us. Even though linked lists, queues, and stacks have an O1 of delete and insert, it doesn't matter because we are going to keep the table as it is. So that characteristics of the other data structures don't matter to us. And comparing all these characteristics and complexity of arrays to other data structures, the ones that matched our needs more were arrays. Para utilizar este sistema, primero tienes que tener un archivo ya creado, que es donde el sistema va a guardar los statements para la base de datos. Entonces aquí tenemos el array que lo que tiene es el CSV, que en este caso es, por ejemplo, es como una lista de una tienda de arte o algo así. Entonces aquí luego tenemos el array que guarda los tipos de datos, crea el statement de crear una tabla en MySQL, que es así, que esto para que ya tengamos una tabla donde meter las columnas con sus tipos. Entonces se va a database statement, que lo que hace es primero crear una matriz transpuesta, porque al usarla normal no acomodaba la información correctamente en el nuevo file. Entonces creo una transpuesta que lo que hace es cambiar el orden de la tabla nada más. Y luego se va columna por columna llamando a las funciones de match y de second match. Match lo que hace es que checa la columna, o sea, checa los valores de cada columna, los va checando y te va diciendo si es int, si es string, si es char, bool o float. Entonces, eso como para tener primero las referencias principales, por así decirlo. Second match lo que te dice es, si es un int, ¿qué tipo de int es? Aquí están las funciones que lo que hacen es como igualar los valores. O sea, son las características que tiene que tener la variable para que haga match con ese tipo. Entonces te dice qué tipo de int es y te regresa ya el metadata, por así decirlo. Aquí lo que hace es crear ya el statement en el file donde te diga alterar tabla y añadir esta columna con el tipo que ya obtuvimos de las otras dos funciones. Entonces después lo que hace es ir insertando valor fila por fila los valores en la tabla ya creada. Entonces si lo corremos se vería de la siguiente forma con este ejemplo específico. Y aquí te aparece el CSV enter will create the next table y te aparece crear tabla con tales columnas de tal tipo y insertar los valores tal hasta que se acabe la tabla.